Hello students. Welcome back to class. Today, we are going to explore electromagnetic field part 2. But before we get started, let's quickly recap what we covered in our last lesson. In our last class, we explored two major concepts. First, an electromagnetic field, which is created when electric and magnetic forces work together. For example, when electric current flows through a wire, it produces a magnetic field around it. Secondly, we also discussed about interaction between magnetic field and currents. When a current-carrying solenoid is placed in another magnetic field, it interacts with the external field, causing the solenoid to move, rotate, or attract nearby magnetic materials. This principle is what makes electric motors work. Today's objectives is to explore the applications of electromagnetic field and electromagnetic induction. Our first objective today is the applications of electromagnetic field. Electric motor. An electric motor is a device that converts electrical energy into mechanical energy. It works by using coils of wire placed in a magnetic field along with a part called a commutator. When electric current flows through the coil, it interacts with the magnetic field, and this interaction produces a force that causes the coil to rotate. This rotation is used to do work in machines like fans, electric cars, and blenders. Moving coil galvanometer. A moving coil galvanometer is an instrument used to measure small electric currents. It has a coil placed between magnets, and when current flows through the coil, it interacts with the magnetic field and causes the coil to rotate slightly. Spiral springs are attached to the coil to provide a restoring force and keep it in balance. The amount of rotation is shown by a pointer, which helps us measure the size of the current. Induction coil. An induction coil is a device used to step up voltage through the process of electromagnetic induction. It contains two coils, a primary coil and a secondary coil. When the current in the primary coil is repeatedly turned on and off, it creates a changing magnetic field. This changing field induces a higher voltage in the secondary coil. Induction coils are commonly used in car ignition systems and devices that require high voltage, like X-ray machines. You're doing great, keep pushing forward. Let's explore how electricity can be generated using magnetism. Faraday's law. Faraday's law helps us understand how electricity can be produced from a magnetic field. It says that a changing magnetic field can induce or produce an electric current in a wire. This means if you move a magnet through a coil of wire, or move the coil in a magnetic field, electricity will be generated. This principle is used in generators to produce electricity. Motor generator effect. This refers to the relationship between motors and generators. In simple terms, a motor converts electrical energy into mechanical energy. A generator does the opposite. It converts mechanical energy into electrical energy. Both devices work using magnets and coils, and they depend on electromagnetic principles to function. The same basic setup can either run a motor or generate electricity. It depends on what energy you're putting in and what you want out. Eddy currents. When a magnetic field passes through a metal like copper or aluminum, it can cause tiny loops of electric current to form inside the metal. These loops are called eddy currents. Eddy currents can cause energy loss because they produce heat. That's why engineers often try to reduce them in devices like transformers and electric motors by using thin, layered materials. However, eddy currents are also very useful in some situations, like in induction cookers, where they help generate heat to cook food, or in the braking systems of trains, where they help slow down the train smoothly. You've come to the end of this lesson. Congratulations. Try these questions to see how much you remember. It is a fun and engaging way to reinforce your learning. Today, we explored the concept of the applications of electromagnetic field and electromagnetic induction. I hope you found the lesson both engaging and insightful. In our next class, we'll begin a new topic, simple AC circuits. Thank you.